How can a machine weighing hundreds of tons possibly leave the ground and fly through the sky? At first, it seems impossible. A commercial airplane can weigh hundreds of thousands of kilograms, yet somehow it can rise into the air and travel thousands of kilometers. The secret isn't that airplanes are light. It's that they are designed to work with the air. An airplane flies because four main forces act on it: gravity, lift, thrust, and drag. Gravity pulls the airplane toward the ground. Lift pushes it upward. Thrust moves it forward. And drag pushes against its movement through the air. When an airplane is flying steadily, these forces are carefully balanced. Lift is strong enough to counteract gravity, while the engines provide enough thrust to overcome drag. But where does lift come from? Look at an airplane's wings. They're not simply flat pieces of metal. Their shape is carefully designed to interact with moving air. As the airplane moves forward, air flows around the wings. The wing changes the direction of the airflow, pushing air downward. According to Newton's third law, when the wing pushes air downward, the air pushes the wing upward. This creates lift. The shape and angle of the wing also create differences in air pressure around it, contributing to the upward force. But there's an important detail: an airplane doesn't need to be lightweight to fly. It needs enough lift to support its weight. That's why large airplanes have enormous wings. A Boeing 747, for example, can weigh hundreds of tons when fully loaded. But its wings provide a huge surface area for interacting with the air, allowing them to generate enough lift to keep the aircraft airborne. Then there are the engines. Jet engines don't simply push the airplane upward. Their primary job is to produce thrust, accelerating the aircraft forward. The faster the airplane moves through the air, the more air flows over the wings. This allows the wings to generate more lift. Eventually, the airplane reaches a speed where the lift becomes greater than the airplane's weight. That's when it takes off. This also explains why airplanes need runways. They don't simply jump into the sky. They need to accelerate to a specific takeoff speed before the wings can generate enough lift. And once the airplane is in the air, the pilot and flight computers constantly adjust the aircraft's speed, angle, and control surfaces to maintain stable flight. So what happens if the engines stop? Surprisingly, an airplane doesn't simply fall straight out of the sky. As long as it has enough forward speed, the wings can continue producing lift. The airplane becomes a glider. Pilots are trained to use this ability to find a suitable place to land if necessary. The same basic principles work for tiny aircraft and enormous passenger jets. Whether it's a small paper airplane, a fighter jet, or a massive commercial aircraft, the fundamental idea is the same: move through the air, generate lift, and control the forces acting on the aircraft. So the next time you're sitting inside an airplane thousands of meters above the ground, remember what's really keeping you up there. It's not magic. It's not because the airplane is light. It's because its wings are turning the movement of air into an upward force strong enough to fight gravity. Hundreds of tons of metal can fly because the air around us is far more powerful than it looks. And that's one of the most incredible examples of physics hiding in plain sight. If you enjoyed this video, like and subscribe for more fascinating explanations of how the world around us actually works. Thanks for watching, and I'll see you in the next video.